What if you could, really shorten your path to building intelligent systems, even if you're not exactly a machine learning guru?
Right.
Imagine just harnessing the power of advanced AI models like GPT
Yeah.
to create things you maybe only dreamed of before.
That's the promise, isn't it?
Exactly. So today we're taking a deep dive into the practical wisdom from OpenAI GPT for Python developers
No.
by Aymen El Amri. And this isn't just a simple book summary.
No, not at all.
It's more like a guide to extracting the really vital, actionable knowledge you need to actually start applying OpenAI's cutting-edge models.
Yeah.
Like right now.
Yeah, our mission here is to cut through all the noise.
Yeah.
Give you a clear, efficient path to using these really powerful tools.
And by the way, this deep dive is brought to you by EasyMasterAI.com.
And what I find really compelling is the author's whole approach.
Yeah.
Aymen El Amri, he's described as a polymath software engineer, right? Broad background.
Yeah.
He specifically made this guide super accessible for Python developers.
Yeah.
His goal wasn't to drown you in heavy theory. It was to provide hands-on practical info, especially if you don't have a deep background in, say, natural language processing or generative pre-trained transformers.
So he basically wants to equip you to build intelligent systems without needing, years of study first.
Precisely. Get you building.
And we promise you, listening right now, we'll unpack the core concepts, we'll highlight some surprising insights, and really showcase the real-world applications that make this guide stand out. We want you to feel empowered, not, overwhelmed by all the tech details.
Okay, so to kick off this deep dive, let's maybe clear up some of the buzzwords first. There's so many flying around.
Oh, yeah. ChatGPT, GPT, GPT-3, DALL, Codex. Where do you even start?
Well, let's break it down. At its core, GPT-3 is a foundational language model. Think massive, trained on huge amounts of internet text.
Okay.
ChatGPT, then, is a specific application built on top of that. It's optimized for conversation, like a specialized chat assistant.
Got it. So ChatGPT uses GPT-3, but it's tailored for chat.
Exactly. Then you have DALL-E, which shifts to the visual side. It generates images from text descriptions.
Right, the image generation thing.
And Codex is another descendant, but it's fine-tuned specifically for understanding and generating computer code. Across lots of languages, actually.
Okay, so they're all related, but distinct tools within the OpenAI family. Understanding that helps see the bigger picture.
It's crucial context.
And speaking of that bigger picture, the book emphasizes OpenAI's overall mission, right? Fostering friendly AI in a way that benefits humanity as a whole.
Yes, that's their stated goal. And the guide highlights how they make this accessible mainly through APIs, application programming interfaces.
Which for Python developers is just a huge deal.
Absolutely. It means you're not wrestling with the, frankly, mind-boggling complexity of training these giant models yourself. You're just making straightforward function calls to tap into that intelligence. It abstracts away all the really heavy lifting.
And that design makes your code more future-proof too, doesn't it? Because you can often switch to newer models just by changing an API parameter.
That's a key benefit. And it also helps navigate the constant hype around new models. The book actually touches on the GPT-4 buzz.
Oh yeah, that viral chart. Comparing GPT-3's parameters to GPT-4's supposed, 100 trillion?
The one with the tiny dot next to the giant circle, yeah.
Yeah.
Everyone saw that.
It really grabbed attention.
But, and this is important context the book provides, OpenAI CEO Sam Altman directly called that specific chart complete bullshit.
Right, I remember that. He was pretty blunt.
Very. And he was also really cautious about even confirming a release timeline back then, saying people were begging to be disappointed.
So the point is, while models evolve, the underlying principles and the practical knowledge in this guide remain relevant.
Exactly. It's about understanding the how, not just chasing the latest model number. The core mechanisms are what matter for developers.
Okay, so beyond ChatGPT, which everyone knows, what are some real-world examples? Where are these models actually being used?
The applications are incredibly diverse. Think GitHub Copilot that uses Codex to help developers write code faster.
Use that all the time. It's amazing.
Then you've got content creation tools like Copy.ai and Jasper.ai, which are, revolutionizing marketing copy, even in fields like medical research. Drexel University used GPT-3 for helping detect early signs of Alzheimer's.
Wow.
And companies like Algolia are using these models to make their search engines way smarter. The impact is already huge and widespread.
It really is. Okay, so let's dive into the actual models the book covers. It breaks down the GPT-3 family, right?
Yes, it presents them as a kind of tiered system. different capabilities, different costs, different accuracy levels.
All right, lay it out for us.
Okay, at the top you have DaVinci. Specifically text DaVinci 003 in the book's context. This is your premium option.
The most powerful one.
Most capable, highest quality output, trained on data up to June 2021. It can handle up to 4,000 tokens. OpenAI generally recommends it for the complex stuff.
Like what kind of stuff?
Things that need really nuanced instruction following, or what they call zero-shot tasks, where it figures things out without prior examples.
Okay, DaVinci is the top dog. What's next?
Next down is Curie. Text Curie 001. Still very powerful, but significantly cheaper than DaVinci.
Ah, cost efficiency.
Yeah.
Important.
Definitely. It was trained up to October 2019, handles 2,048 tokens. It's a good choice for things like translation, complex classification, text analysis, summarizing, a real workhorse.
Makes sense. And below Curie?
You have Babbage. Text Babbage 001. This one's more for simpler tasks. Good for basic categorizations, semantic classification, same token limit and training date as Curie.
Gotcha. And the last one?
That's Ada. Text Ada 001. This is your super fast, very cost-effective option. Best for the simplest classifications, quick text extraction, maybe correcting addresses, things like that.
So a range from super powerful to super fast and cheap.
Exactly. And the book also specifically mentions the Codex models for code.
Right, for the programmers.
Yeah, Code DaVinci 002 is highlighted for being great at translating natural language into code. Supports up to 8,000 tokens, which is quite a bit.
And the other Codex model?
Code Cushman 01. Also powerful and fast for many code generation tasks, but generally more affordable than the Codex DaVinci. Gives you options.
Okay, that's a good breakdown. What about safety? Does the book cover that?
It does. It mentions the content filter. It's optional, but OpenAI highly recommends it, especially for public-facing apps.
What does it do?
It classifies the text generated by the API into categories like safe, sensitive, or unsafe. It's a crucial layer for responsible AI use, basically.
Good to know. And there was a terminology change too, right? Engines versus models?
Yes, a small but important point the guide clarifies. OpenAI switched from calling them engines to models.
So use model in new code.
Right. Older API calls might still work with engine for backward compatibility, but for anything new, you should use model.
Okay, so when you're starting a project, how do you choose? DaVinci sounds great, but maybe overkill.
That's the core trade-off the book emphasizes. DaVinci gives you top quality, but it costs the most. Curie, Babbage, Ada offer ways to optimize for cost on simpler tasks.
So don't just default to the biggest one.
Exactly. You need to match the model to the task complexity for both performance and cost. It's a strategic choice.
And the book mentions something that makes trying this out easier, right? The free credits.
Ah, yes, that's a great point. OpenAI offers, or at least did offer, $18 in free credit for the first 3 months when you sign up.
Which is pretty generous. Enough to experiment.
For sure. It really lowers the barrier to entry, lets you get your hands dirty and try things out without worrying about the cost immediately.
Okay, so we understand the models, the cost trade-offs. How do we actually talk to these AIs? Let's get into the practical side.
Right. This brings us to the core mechanism, GPT text completions. The OpenAI completion API is really central to a lot of what you'll do.
And how does that work, fundamentally?
It's pretty intuitive. You give the AI a prompt, which could be the start of a sentence, a question, a set of instructions.
Like giving it a starting point.
Exactly. And the model then predicts and generates text to complete that prompt.
Simple enough. But you mentioned tokens before. How do they fit in here?
Tokens are absolutely crucial for understanding completions, especially pricing. One token is roughly maybe 4 letters of English text.
Okay.
So a quick rule of thumb is about 100 tokens equals 75 words. This unit measures both your input prompt and the generated output.
And that directly impacts how much you pay.
Directly. So managing token count is key.
And the guide shows you how to control the output, right? It's not just a black box.
Definitely not. You have parameters like max tokens to limit the response length. You can use the N parameter to ask for multiple different completion choices at once.
Oh, so you can get options.
Yes. And there's even a best of parameter where the server generates several completions internally and sends you back the ones it thinks are best, which can improve quality.
Interesting. What about controlling the style of the output? Creativity versus predictability.
That's where the temperature parameter comes in. Okay. It's a really important one. Lower temperature means more focused, deterministic output.
More predictable.
Right. Higher temperature encourages more creativity, diversity, sometimes even randomness in the output.
So you can tune how imaginative you want the AI to be.
Exactly. And you can also define stop sequences, like telling it to stop generating when it hits a new line character, effectively ending a paragraph.
Useful for formatting.
Very. And there's even a suffix parameter you can sometimes use to add text after the completion, maybe to help structure the output, like closing off a JSON object or a Python dictionary.
Wow. Okay. So combining the prompt with these parameters gives you a lot of control. The book must have some cool examples.
It does. It shows things like generating keywords from a block of text, crafting tweets, even generating a rap song based on a theme.
A rap song? Seriously?
Seriously. And a really practical one walks through creating a detailed to-do list for starting a company in the US. It just shows the versatility.
That really drives home how flexible that completion API is. But generation is one thing. What about changing existing text?
Ah, yes. That leads us to the next major capability the book covers: editing text with GPT.
Okay, now this sounds really interesting. How does that work?
It's slightly different. You provide an input text, the text you want to change, and crucially, an instruction telling the model how to change it.
So you need to be specific about the edit.
Yes, the instruction is required. Though interestingly, the input text itself is technically optional. You could embed the text to be edited directly within the instruction sometimes.
Flexibility again?
Right. And the guide points out that some tasks, you could actually achieve them using either the edits endpoint or the completions endpoint with clever prompting. It gives developers options.
And I assume parameters like temperature are important here too.
Absolutely. Just like with completions, temperature and another related parameter, top, help you balance creativity versus sticking closely to the instruction for precise edits. Fine-grained control.
Got it. So you can generate and edit. What about combining these things?
That's where it gets even more powerful. The guide shows how you can chain completions and edits, stringing together multiple ATI calls.
Like a workflow.
Exactly. Imagine generating a summary of an article using a completion call, then immediately feeding that summary into an edit call with an instruction like, make this tweetable, and then feeding that tweet into another call to translate it.
Whoa. Okay, that opens up possibilities for complex tasks.
Multi-step processes become feasible. And then there's another technique the book details, which you found interesting: context stuffing.
Yes. This seems like a really clever way to get better results. Tell us about that.
So context stuffing is all about providing the model with extra information within the prompt itself to guide its output.
Like giving it hints.
More than hints. Could be examples of the kind of output you want, relevant background information, maybe even a specific data schema it should follow.
Why is that so useful?
Because it helps the model disambiguate. Think about the word apple. Does it mean the fruit or the company? Context tells it.
Ah, I see.
By stuffing the prompt with relevant context, you make the model much more precise for your specific need. You're essentially programming its understanding on the fly for that particular request.
That sounds incredibly powerful for specialized applications. Less generic, more tailored.
Precisely. It helps reduce those weird, incorrect hallucinations AI can sometimes produce.
Does the book give examples beyond the Apple one?
Oh, yeah. It shows how to use context stuffing to extract cryptocurrency info based on a specific schema you provide in the prompt, ensuring the output is perfectly formatted.
Nice.
Another really cool example is building a conversational Linux assistant. It uses context in Python's Click library to translate your natural language questions like, how do I list files, into the actual ILS command.
Okay, that's taking it from theory straight into a useful tool.
It really demonstrates the practical power.
All right, this is fascinating. What other advanced techniques does the guide cover? I remember seeing something about embeddings.
Ah, embeddings. Yes, this is a really fundamental concept in modern AI, and the book explains it well.
So what are embeddings, in simple terms?
Think of them as numerical representations, basically. Lists of numbers or vectors for pieces of text. But they're not random numbers.
Okay.
They're designed so that texts with similar meanings end up having similar numerical representations. They capture semantic relationships.
Meaning they understand the meaning, not just the words.
Exactly. Meaning, sentiment, context. It's all encoded in these numbers. Words like king and queen would be mathematically closer than king and cabbage.
Got it. Like coordinates on a map of meaning. What can you do with these embeddings?
A ton of stuff. The book lists use cases like semantic search, finding things by meaning, not just keywords, clustering similar documents, building recommendation engines.
Like people who read this also read.
Precisely. Also, anomaly detection, finding outliers, and classification tasks.
Are there real-world examples of companies using these?
Absolutely. The guide mentions Tesla using embeddings in their self-driving tech, likely through transfer learning. Calendar AI uses them to match sales pitches better, significantly reducing unwanted outreach.
That's impressive. 56% reduction. Wow.
Yeah. And Notion uses embeddings to power its search, making it much smarter than basic keyword search. Even DALL-E 2 uses image embeddings internally, specifically CLIP embeddings.
So how do you actually do semantic search with this?
The process involves first converting your text, say your documents and the user's search query, into these embedding vectors. The book recommends OpenAI's text embedding ADA 002 model for this.
Why that specific model?
OpenAI promotes it as being better, cheaper, and simpler than their older embedding models.
Okay, so you have the vectors. Then what?
Then you calculate the similarity between the query vector and all the document vectors. A common way is using cosine similarity.
Cosine similarity sounds mathematical.
It basically measures the angle between the vectors in that high-dimensional space. Smaller angle means they point in a similar direction, meaning they're semantically similar.
So office vector would be closer to desk vector than to necklace vector.
Exactly that. It finds meaning-based relationships.
And the book mentions that helps with fuzzier searches too, like typos.
Yes, because you're comparing meaning, not just exact characters. It can find desk, even if user type DSEC or maybe a work table. You compare the embedding of the user's query to embeddings of known terms or documents.
That's a huge improvement for user experience. What about classification?
The guide shows a cool technique called zero-shot classification. You can classify text, say, predicted news articles category, sports, tech, without any specific training examples for those categories.
How?
You create embeddings for the article text and also for the category names themselves. Then you see which category name embedding is most similar to the article embedding using cosine similarity.
Whoa, so the model just figures it out based on the meaning of the category name.
Pretty much. And the book even shows how to use standard Python libraries, like sklern.metrics.precision score, to test how accurate this zero-shot classifier is on a dataset.
That's really powerful. But sometimes you need more accuracy, right? That's where fine-tuning comes in.
Exactly. Fine-tuning takes things a step further than providing examples in the prompt, which is called few-shot learning.
Okay, what's the difference?
Fine-tuning lets you train the base OpenAI model on a much larger data set of your own examples, way more than could ever fit in a single prompt.
And what's the benefit of doing that?
Several big ones. You typically get significantly higher accuracy on your specific task. The model becomes better at handling a wider range of inputs related to that task. And often, fine-tuned models can be faster and cheaper to run for inference because the specialization is baked in.
So you're creating a custom expert model.
That's a great way to put it. You're specializing the general AI for your specific domain.
Are there best practices for doing this? The book must cover that.
Oh yes, crucial advice. Use JSON format for training data. You need a good number of high-quality examples. The guide suggests at least 200, ideally human-checked.
Quality over just quantity.
Definitely. And specific formatting matters too, like adding a consistent white space at the start of your desired completions and using fixed stop sequences so the model knows when to finish.
What about choosing a model for fine-tuning? Still Da Vinci.
Not necessarily. For classification tasks, the book actually recommends starting with ADA. It's fast and cheap to fine-tune and often performs surprisingly well for classification after tuning.
Interesting. Save the big guns unless needed.
Right. And it also suggests an efficiency trick. Use single tokens like 1, 2, 3 as your class labels instead of full words like sports, tech. It's faster and cheaper.
Clever. Does the book have a really compelling example of fine-tuning in action?
It has a fantastic one. Building a chatbot to classify drugs based on the maladies they treat.
Okay, how does that work?
First, you fine-tune a simple model, maybe ADA, on examples linking drugs to maladies like acne, allergies. This model learns to output just a simple class token like 0 or 1.
So it just does the classification?
Yes. But then you combine this specialized fine-tuned classifier with a powerful general model like text Da Vinci 003.
How?
The user asks a question. The fine-tuned model quickly classifies the relevant melody. Then that classification is fed into a prompt for the Da Vinci model, which generates a helpful conversational response about that melody and related drugs, drawing on its broader knowledge, but guided by the fine-tuned classification.
So it's a two-step process using the strengths of both models.
Exactly.
Got it.
It creates an intelligent assistant that provides useful info, but also includes responsible disclaimers about not being medical advice. And the guide even discusses deploying it as a web app using Vue.js and Flask.
That's a really sophisticated yet practical application. Okay, we've covered text. What about other modalities? Speech, images.
The book definitely moves into those areas too. It introduces OpenAI Whisper.
Whisper. That's their speech-to-text system, right?
Yes, their general purpose automatic speech recognition, or ASR, system. And it's incredibly robust.
But robust how?
It's surprisingly good with different accents, background noise, even technical jargon. That's because it was trained on a massive data set, 680,000 hours of diverse audio.
Wow, that's a lot of data.
It is. And it can transcribe audio in multiple languages, plus translate many of those languages directly into English text.
So it's multilingual and does translation too.
Correct. The guide mentions there are 5 different model sizes, offering that familiar trade-off between speed and accuracy. And it points out that performance does vary by language, referencing a word error rate chart for specifics.
Okay, so Whisper gives you powerful transcription. How does the book suggest using it?
Well, by combining these tools, it lays out how you could build your own voice assistant, kind of like Alexa.
Really? How would that work?
You'd use a Python library like speech recognition to capture audio from the microphone. Pass that audio to Whisper for transcription.
Okay, now you have text.
Right. Feed that text query to GPT-3, maybe Da Vinci, to get an answer. Then use something like Google Text-to-Speech, GTTS, to convert GPT-3's text answer back into audible speech.
So mic size per whisper last GPT-3 speaker, that's the flow.
That's the core loop. And the book explains using a multi-threaded approach to make it feel seamless.
Multi-threaded.
Yeah, one thread handles recording, another handles the whisper transcription, which can take a moment, and a third handles getting the GPT-3 reply and playing it back, so it doesn't feel laggy.
Clever engineering, making it feel responsive.
Exactly. And it gives tips on structuring the prompts for GPT-3 to get better voice assistant-style answers, and how to handle errors gracefully.
Very cool. Okay, speech covered. What about AI that sees images?
The guide touches on that too, starting with image classification using OpenAI CLIP.
CLIP, I've heard of that. What's the key idea?
CLIP is a neural network trained to understand images based on natural language descriptions. Its big advantage is enabling zero-shot image classification.
Zero shot for images, meaning?
Meaning it can recognize or classify objects and concepts in images,
Yeah.
even if it wasn't explicitly trained on those specific things during its initial training phase. You just give it the image and text descriptions of what you're looking for.
That sounds incredibly flexible for developers. No need for massive custom image data sets for every new task.
Huge advantage. And then, of course, the book gets to the really hot topic, generating and editing images with DALL.
Telly, along with Stable Diffusion, Midjourney. This stuff exploded.
Absolutely. It really made prompt engineering a mainstream skill. The basic idea is simple. You give DALL a text prompt.
A photo of an astronaut riding a horse in space.
Exactly like that. And it generates images based on your description.
Yeah.
You can ask for multiple images, control the size, etc.
But the magic is in the prompt, right? The book must offer tips there.
Oh, definitely. Crafting good prompts is key. It shows how you can guide the output by mimicking specific artists in the style of Van Gogh, or maybe Masashi Kishimoto from manga style.
Okay.
Specifying art styles, Art Nouveau, cyberpunk, watercolor painting.
Makes sense.
Evoking atmosphere, adding phrases like peaceful atmosphere, or a feeling of intense fear.
Getting the mood right.
Controlling colors explicitly, a vibrant red sky, cool color gradients. Specifying camera shots, close-up, wide angle, aerial view.
Like directing a photographer.
Pretty much. Even mentioning lens types, telephoto lens, camera settings, shallow depth of field, f1.8 aperture, film stock, shot on Kodachrome, or even specific Instagram filters.
Wow, that's getting really detailed. You can really art direct the AI.
The level of control is amazing. The book even mentions the idea of creating a random image generator by dynamically combining prompt elements.
That could be fun. But DALL isn't just generating from scratch, right? It can edit, too.
Correct. Image editing is another powerful feature. You take an existing image and you provide a mask.
A mask? What's that?
Think of it like selecting an area in Photoshop.
Yeah.
It's usually a transparent area you define on the image. You then provide a prompt describing what should go into that masked area.
So like adding something that wasn't there.
Exactly. The example given is adding hikers onto an empty forest path image by masking part of the path and prompting hikers walking along the path. DALL-E fills in the masked area based on the prompt and the surrounding image context.
That's incredibly useful for modifications.
And finally, there's image variations. Once you have an image you like either generated or edited, you can ask DALL-E to create several similar variations of it.
So you can iterate and refine the result.
Precisely. It helps you hone in on the perfect image.
Man, we've covered a lot of ground, from understanding the basic models and APIs.
Right, through text completion, editing, context stuffing, the power of embeddings for search and classification.
Then fine-tuning for specialized tasks, Whisper for speech recognition, CLIP for image understanding.
And finally, DALL-E for image generation and editing. It's quite a toolkit.
It really is. This deep dive, pulling from OpenAI GPT for Python developers, just shows the sheer potential these tools have, especially when you start combining them.
And the key takeaway, I think, is that Aymen El Amri successfully shows you don't need to be a top-tier AI researcher to start building genuinely intelligent, impactful applications with these OpenAI models.
The barrier to entry is lower than many people probably think, especially for Python developers.
Definitely. The APIs abstract so much complexity.
So here's a final thought for you, the listener. Now that you have this clearer picture of these powerful AI building blocks, what problem out there could you tackle?
Or what creative project, maybe something you've put off, could you finally bring to life using these tools?
The possibilities are vast. And if you want to dive even deeper, explore more AI tools, and really learn how you can leverage this technology to create new opportunities, maybe even start a business or generate income, we strongly encourage you to visit easymasterai.com.
That's easymasterai.com. It's your next logical step to really mastering AI for practical, real-world impact.